So you got intermediate value theorem, and you got the mean value theorem. The third theorem, notice the number 3, Jonah, is the extreme value theorem, or what's called EVT. And this has to deal with continuity, that something's continuous. You know how the mean value theorem is derivative and the intermediate value theorem is continuous? This one's also continuous. And it says if you have a closed interval from A to B, then F has to have at least one minimum value and at least one maximum value in that interval. There's got to be at least one. So I'll give you some examples. I'm going to write EVT right here. And I'll give you 2 examples. So I have a closed interval. That means it's going to have an endpoint. And I'm going to draw it continuous. So this right here would be the max. This point right here. And this would be the min. And we call it the absolute max, and we call it the absolute min. Okay? So 2 things about this beautiful drawing I made, Owen. Okay? First of all, the extreme value theorem, you don't have to look at every point in the interval because there's an infinite number of them, correct? So they're only going to occur at these 2 places, at the endpoints or at what we call these turn around points. Okay, notice I didn't say vertex because it's not parabola, but it is a turn around point because it's rising, and then it pauses and turns around. This also rises and and turns around, but it's pretty easy to see that this y value is bigger than this y value, correct? So you have, like if this one came up and was the same height, you would have 2 maxes. That's okay. You have to have at least one. Usually, I have a student that says, hey Kruger, what about this one? One that's horizontal. Well, it means all the y values, all of them, remember it says at least one, you have more than one, you have all of them are the max and mins at the same time. Is everybody okay with that? All right. So I'm going to write that down here. All right. And then we're going to have these terms. All right. Now, I live by North Junior High, if any of you have any idea where that is. I live in a cul-de-sac, okay? And there's probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 homes in that cul-de-sac. Out of the 11, someone makes the most money. There's a household that makes the most money. You could figure that out if people would share that information, right? Okay? That is a local maximum. Because I can guarantee you, the people that live in my cul-de-sac aren't the richest people in the world. One, they live in our cul-de-sac, right? If I had the most money in the world, Audrey, I'd live in Hawaii. And then I'd have another home. Oh, I don't know, maybe Greece. And then I'd have another home, maybe New Zealand. And I'd spend 4 months at each of those places. I would not live in the cul-de-sac, okay? The richest person in the world, which is somebody that...
Elon Musk.
Is it, right now?
Apparently.
Or has he lost money because he bought what used to be Twitter, and now it's called X?
Hey, either way, I win. Either Twitter gets better or it dies. Either way, I win.
Okay.
Elon Musk buying Twitter was a great decision.
Well, anyway, there's one person that is the greatest person in the world, right? The richest person. Now, that is called a global maximum. Does that make sense?
And then
Right.
it is probably a
So
universal
then we're gonna
maximum.
have these other terms, and these terms are used both by AP. And so if you see low extrema is either a max or min. It has the word extreme in it, so it's either gonna be a maximum extrema or a minimum extrema. Global and absolute are the same. You will probably hear me say absolute the most. Then you have this local and relative. They are the same. And I'll talk about what relative means in a bit. I will use relative as the most, okay? Going to this biggest picture, let's say this is the x-axis. This is not the absolute maximum, would you agree? But, and this is what we actually call it in mathematics, down here I can create a little interval, like my cul-de-sac. We call that in math, and it's true, a neighborhood.
Mr. Rogers intensifies.
And right here, this is the maximum in this neighborhood. This is the maximum in my cul-de-sac. So we call it a relative maximum, because it's not the maximum in the interval, but in there, it's a maximum of a neighborhood, of a cul-de-sac, of a small group of x values. Okay, that'll make sense? All right.
Unfortunately, I can't label it.
All right, so here I have a piecewise graph. And let's take a look at some points. Let's take a look at this value right here, this y value. How would you label this? Would it be an absolute max, an absolute min, a relative max, or a relative min? Tyler, what do you think?
Absolute.
Absolute min. Can you tell me why you think that's true? It is true, but can you tell me why?
It's the lowest point on the entire interval.
It's the lowest point in the entire interval. Would you agree? All right. Let's take a look at this Jonah. This one doesn't exist, so this is my y value given this x. Would you agree?
Yeah.
So there's a y value here. How would you label this?
The absolute max.
Absolute max. And the reason why?
Is higher than every other point.
It's higher than every other y value,
Holds
correct?
the highest y value, and it ain't undefined.
Within that interval.
Indeed.
Okay. Now, Maria, what about this one right here? So I could make a little neighborhood, right? This x value is in that neighborhood. So I'd look here, and I'd look here. What can you tell me about this? Is it a minimum? It's a relative minimum because I can create a neighborhood in which it's the smallest. It's not the smallest overall, right? Because Tyler said this is the smallest. But within this neighborhood that I can create, this would be a relative min. Audrey, what about this? Could I create a neighborhood or an x value that creates that y value? I can, can't I? All right? So what do you say that this is? A relative min also. Because it's smaller than all these other y's, right there around it.
Do a capital R, lowercase m. Lowercase m for minimum.
I write write it like that. All right, what do you notice about this? Here's another point that wasn't shown. What is this? Ella,
No, relative.
relative. All right. Now, here I have an endpoint, right? Everybody with me on this, Callan? This point causes controversy.
May I ask why?
Because, and it's not on the AP exam. So here the question is, why is it controversial? Well, there's a group of mathematicians that say, hey, it cannot be a relative, it can't be, it's not for sure. If you use the extreme value theorem, you could say, hey, it might be an absolute max, it might be an absolute min, correct? But it's neither one of those, right? Because here's the absolute max, here's the absolute min. So there's a group of mathematicians that say that cannot be a relative min because you can't create a neighborhood because you can't go to the right because it ends here. So you can't go to the right of that point. Does that make sense? Then there's a group of mathematicians that say, yeah, but it's below some other y's. So we can call it an absolute min. All right? So the way that I teach this is the endpoints can never be relative. They can only be absolute max or mins. That way, you won't answer those questions. The relative maxes, mins have to be within the interval. If they're the endpoints, they're not relative. So I'm going to write that down. Endpoints are not relative. Because I don't want to have people to have fisticuffs in here. You know, some of you saying, yeah, it is relative. Okay, why isn't it a relative max? How do you know? How do you know it? You don't know what's happening on the other side, right? So that's my argument. It doesn't live on the neighborhood. It could have been, if it kept going up and past this point, it could have been absolute. And absolutes will occur here, or they'll occur somewhere in here. But relative will not be on the end. Are we okay with that? All right. So let's take a look at this. So I wrote a little note here. Only consider endpoints for absolute extrema, not relative. All right. So this is how it says find all extreme values. When it says extreme, they want absolute and relative. Identify the type and weigh their curve. All right, I am going to ask Callan. The absolute min of, so tell me what y value is the absolute min? 1. At x equals what?
-3.
Perfect. Okay, that's how you answer that question. Austin, absolute max of what?
Would be 5,
That's what I got. At what x?
0.
Perfect. And do we have any relative min relative bin, Colin? No. Owen, would you agree with that?
I mean, is one, two?
Well, let's take a look. This is how I do it. Let's make a little neighborhood. Okay? And so I'm going to go from here to here. Okay? And then I'm going to go up. So there's the Y value for this person on this end of the neighborhood. Okay? I don't know those people's names. Okay? And over here, this is about a half. And so this is, I don't know, between 4 and 5, right? And if I take a look, as I move to 1, all the Y values are dropping here. Over here, as I move from 1.5 to 1, all the Y values are dropping here. And this point is defined. So is 2 less than all the Y's that are in the neighborhood?
Yeah.
Does that, everybody, make sense? So I actually physically say, okay, I'm gonna go a little bit to the right, I'm going to go a little bit to the left and see what happens, okay? Now, if this would have went, you know, if I would have went here, had an open circle, and then I had that, it'd still be, right? So there's a relative min of what would you say?
2.
2,
X
because it
equals
exists, correct?
Yeah.
At x equals
1.
1. Everybody okay with that? All right. This one is not defined, is it? Correct? And so this is how I think about this one. If I'm at a negative 2.9, I'm getting closer to 1, like it could be 1.1. As I even get closer, it could be 1.01, but it's never 1, is it? And always, as I get closer, I can always get a little bit lower than the number that I had before, but never be at 1. Does that make sense? Because you can always add numbers at the end of decimals, like forever into infinity, correct? You've seen those kids, elementary. I used to do it with my brothers. Yes, it is. No, it's not. Yes, it is. No, it's not. Seriously, how can you do that for an hour? One of you punch the other one and just move on. Okay. I am not advocating violence in any way. Ben,
Yep.
is there an absolute max?
Yeah.
So you're gonna say absolute max at, oh, a max of,
Negative 1, or sorry, at 3, of 3.
those 3 is an answer. At where?
X equals negative 1.
Perfect. All right, is there a min? Yes, sir.
There is. It's
What
not,
is it?
It is the point 1, negative 3, but approaching that, it is right.
So tell me what it is. What is the lowest Y value?
The lowest Y value would be.
Give me a number.
Okay, that would be 0.9 repeating.
Y value.
Y value would be 2.9 negative 2.9 repeating.
I'd say negative 2.99 is smaller. The more negative is, the smaller the number, right?
That is true.
Can you see our game we're gonna play?
Yes.
Because you're gonna tell me a negative 2.999, and I'll say I could do you one better, a negative 2.991.
Negative 2.9 repeating indefinitely.
That is the same as a negative 3. I've seen the proof, 3 of them.
Well,
So what do you think there is for a minimum?
nothing then.
Does that make sense? That's a tough one. Because there's no value at negative 3. And every time you get closer, okay, somebody can get a little bit further down, right? You're not gonna get to negative 3, but you're gonna get a number that's a little bit. So there is no minimum here. Why can I say that? Because it's not continuous, right? Continuous continuity would guarantee us a minimum, but since there's a break here, there's not gonna be one. You're
Continuity.
guaranteed one if it's continuous.
but continuity is not needed to find a relative or maximum minimum. But if there is continuity, it's guaranteed there. as well.
Right, right, it's a good summary. All right, Tyler, are there any relative ones? I think there is at 1. So I'm gonna make a little neighborhood. Okay? Okay? And as I come this way, I'm gonna have those y values. And as I come this way, I'm gonna have those y values. Is this one bigger than all the y values on the right?
Yeah.
Is this one bigger than all the y values on the left? Is there, in this neighborhood, in this little tiny neighborhood, in Monroe Place, that cul-de-sac, is this one bigger than all the other y's? Yeah, it is. Okay, so I'm gonna say there's a relative what? At, of what, I should say? 1 at x equals 1. Okay? You gotta create that little neighborhood, take a look. Let's take a look at this beautiful graph right here. So this was all about looking at extrema, correct? And identifying extrema, okay? We're gonna take a look at a way of how we can find those extrema, okay? So right here, I have some turning around points. Would you agree? And this is not a closed interval, it goes on forever. And what I want to do is, first of all, draw these lines right here. Now, those I drew because the curve is smooth, it's not pointy. Would you agree? Audrey, I skipped you. How did I skip you? Did I skip you today? I didn't? Okay. Maria, what can you tell me about those horizontal lines on those smooth curves? I didn't quite hear you, I'm sorry. Yeah, they're all tangent lines, and they're all horizontal. So what can you tell me about their slopes? Yes, they are. What is the slope of each of those lines? What? 0. Would everybody agree? And that must mean that the first derivative is equal to 0. Would everybody agree with that? When you get horizontal tangent lines, their slopes are 0. The slope of tangent lines are called the derivative. It means the first derivative is equal to 0. Everybody okay on that? That's a big idea. Okay, Audrey? Can I put a horizontal line there? No. Why? It's a sharp point. But it turns around there, doesn't it? So it's important. So it means I'd expect that the derivative does not exist, right? It's undefined. So, to find these to find these points here, we either have to have the derivative equal to 0 or the derivative does not exist. The derivative equals to 0 or the derivative does not exist. Does that make sense to everybody?
I understand that the derivative is 0 or does not exist, but to find what?
To find where these points, where this graph turns around.
Oh,
Okay?
yep.
Okay. Flip to the next page. A critical point a point that has a possibility Okay, now, I'm gonna tell you also what a possibility was, okay? You've seen me walk around, and when you look at me, you don't look up, do you? You don't even look straight across, do you? Okay? So, when I was born, my dad said, oh my God, he's going to be a giant. Because my hands were big compared to a relative, everything else, okay? The problem is they stayed the same size for the rest of my life, okay? Now, and he said, this kid has a possible to be a basketball player. The possibility, right? Why? Because I had big hands. I didn't have big feet. Okay. Dogs that have big feet are going to be big dogs. You guys know that? Huge dogs. So, there's a possibility. Doesn't mean it's guaranteed, a possibility. A possibility of being an extrema. And what do I mean by extrema? I mean either an absolute max or min, or I mean a relative max or min, or what I could say, Audrey, a turning around point. I'm headed in the other direction. I'm headed home. I'm headed back to school. All right. How do you find a critical point? Well, maybe the derivative does not exist. Maybe the derivative is equal to 0. You have to consider both. Might have a max or min. So I'm going to do 3 problems. I know you only see 2, but there's going to be a third one. So I have this function right here. It's a cubic function, correct? Do you guys learn about cubic functions in pre-calc and FST? Do you or not? Do they kind of go like this? Like that? They don't have to, but they could, right? They're an odd function. You guys know what the heck I'm saying? Have you ever heard any of those terms? Jonah?
A little bit.
A little bit? Okay. So, here's a function. I'm going to find all the critical points, okay? I'm not finding the turnaround points, I'm finding the critical points. So what I'm going to do is I'm going to take the derivative automatically. I don't even know where I am anymore. Jonah, take the derivative for me.
X squared minus 9.
So I take that derivative, and you see line number 2, I make it equal to 0. Can you solve that in your head?
Yeah.
What? And let me tell you, see that squared thing? More often than not, that means you have 2 answers. What's one of your answers?
3.
And what's your other answer?
-3.
Yeah, folks, don't forget the -3.
It may not be as good as the legendary 3, but it's still good.
So these are, I call them, they're not points, so I call them critical values. They are going to be possible minimum or maximum. And you're going to say to me, really, Kruger? That's as hard as it gets? Yep. Audrey, you're next. Okay, now, Audrey, when I see something that looks like a fraction, I'm gonna make this a little bit bigger for you. I know this. Have I told you guys the stories about the birthday party for kindergartners? Yeah? About this one child that did not get invited to the birthday party, right? Okay? Do I have, you're right, they're not a member of the domain, right? Do I have numbers that are not members of the domain?
Yes.
Yes, you do. What are those two numbers?
2 and -2.
Everybody see where that happens? So what she did, I hope she did in her head, she says, okay, I know that 4x minus squared better not be equal to 0, correct? And when you solve that, you get x can't be 2 or a -2, correct? Okay, I'm gonna tell you right now, that's the first thing I look for when I see that. So I know my answers can't be there because those two people aren't at the birthday party. The conjugates aren't there. Bill and Bruce weren't invited, though they were always invited because they were the life of the party. They were always doing shenanigans. Shenanigans is what we used to call it. So, I still have to take the derivative. And Audrey, you're gonna take the derivative, and I'm gonna rewrite it so it looks like this. Are you okay with that form?
Yes.
Okay. So, what's the derivative?
-1/2.
-1/2. 4 minus x squared to what power now?
To the -3.
Perfect. Anything more?
Yes, multiply it by
Negative 2x. That's the derivative of the inside. That's using the chain rule. Notice how we're always doing this stuff, Owen? It's like you never forget. You know what? Another Owen one time, Owen Berg, sat right where Austin is. Do you know, anybody know Owen Berg? Okay. And Owen says, are we going to keep doing this stuff all year long? And I said, yeah. You're not allowed to forget anything. You got to be able to apply the chain rule. It just doesn't go away. So, can we simplify this a little bit? Audrey, I got a negative here, I got a positive here, I got a negative here, correct? So it's going to be positive. The negative signs are gone. Do I have anything in the numerator?
Yes.
Yeah, doesn't the -1/2 and the -2, they're gone. And I know I should use a red pen, but I'm a little tired right now. Okay. So what should I put up here?
X.
And then down here, can I put 4 minus x squared in parentheses to the 3/2 power, right? Now, Ben, this is where you find your zeros. This is where you find your undefined. This is where you find your horizontal tangents. This is where you find your undefined values. Now, so I'm going to take the numerator and make it equal to 0. Well, that's pretty okay. Am I able to put 0 into my equation? Are you allowed to put 0 into there? Was 0 invited to the birthday party? Yeah, because when I put 0 in there, I get 1 over the square root of 4, I get a half, correct? Now, I could go through the effort of taking a look at this denominator and making it equal to 0, but I'm going to get plus or minus 2, correct? Which I've already said cannot be an answer. So if they can't be answers, they can't be critical numbers because we don't even use them to begin with. Right? They're not even in my domain. I can't say they're critical numbers. You've got to be a member of the domain to be a critical number. Are there any people that are in Sartell High School here? No, they're not part of the domain. Okay? So they're not here in this lecture, unless they watch it on YouTube. Everybody got that? So, x cannot be equal to plus or minus 2, not members of the domain. This is a critical number. Why is it a critical number? Simply because it makes the derivative 0. I would have 0 over 4 to the 3/2 power. Everybody okay with that? And 0 over any number other than 0 is 0. 0 over 4 to the 3/2 power, which I think is 8,
So
is
what?
still 0.
So what stops 3 and -3 being automatically critical values?
Because they make the derivative 0. They make the derivative 0.
But what stops 3 and -3 from automatically being critical values? They're not only critical possibilities.
No, they're automatically critical values. We don't know if they're maxes or mins. To be a critical number, you simply have to make the derivative 0 or make it undefined. That's all you have to do,
Okay.
okay? It doesn't mean you're guaranteed to be a turning around point, okay? And we're gonna learn a method on how we determine whether they are.
Okay, it's slightly confusing now, but okay.
Here's question number 5. F of x equals x to the 2/3 power. And my domain. Ella, is there any number I can't put in there?
I don't think so.
Because the third means I can take the cube root, correct? And then whatever I get as the cube root, I'm gonna square it. Can you take the cube root of a negative number?
Yeah.
Yeah, and then you can square it, it becomes positive, right? So like the cube root of a -1 is a -1, and when I square it, it becomes 1. If I have -8 in here and take the cube root of a -8, well, -2 times a -2 times a -2 is -8, right? So I'd get -2 here, I'd square it, I'd get 4, okay? So you would tell me the domain is what? All reals, which, I don't know, I always thought that was kind of a cool R. You guys remember when Prince changed his name to a symbol?
New Prince,
You guys know who Prince was?
Unity Sing Purple Rain.
Yeah, but he, for a while, he dropped his name and went to court, made it a symbol. And the reason he did that, so he could get all of his music back, dealing with the music company. Okay. Well, someday, you're gonna say, I wonder whatever happened to Mr. Kruger? And I won't be listed, but that symbol will be. I'll just do it I wonder if my wife will be bothered by that. She'd be Mrs. This. All right, back to you, Ella. What's the derivative?
2/3 x to the -1/3 power.
Perfect, just like that, right? Would everybody agree? To find the critical number, Ben, we cannot leave it like this. So, Ella, is this thing a fraction?
Yeah.
So I gotta draw that bar, right? Is there anything on top?
2,
2. Is there anything on the bottom?
3.
Anything else?
The cube root of x.
Perfect, you said it just the way it's like I paid you, right? Would everybody agree with that? So now I'm looking for critical numbers. They're either gonna be in the numerator or they're gonna be in the denominator. Now, Ella, since you're on board here, can 2 be 0?
No.
Never. Mr. Carr shows me $2. He can't say, no, they're the same as 0. No, you owe me $2. All right? Can the cube root of x be 0?
I think so.
Okay. X equals 0. X would be, the cube root of what number is 0?
0.
0. Was 0 allowed up here? You said all reals. Is 0 a real number? Yeah. Guess what? It's a critical number. Now, I'm going to answer your question 1 second. I graphed this, remember I'm graphing this. Get rid of that, you don't want to see that. So I'm gonna put x raised to the 2/3 power. There it is, right there. I'm gonna hit draw. Look at that. It's continuous, isn't it? It's a absolute minimum, isn't it?
But
But what?
it's a sharp point.
It's a sharp point. So anytime you get these zeros in the denominator, and they can be used, they're part of the domain, they are sharp points. The ones that are in the numerator are smooth points. I'm getting a haircut on Friday. You guys gonna take a razor blade, like that big razor blade? I've never had that done. Okay, is that making sense now? Is that putting it all together? Okay, yes, sir.
You could also try making x infinity, because the cube root of infinity would be infinity. Infinity times 3 is infinity. Anything over infinity is 0, except for infinity.
I don't understand what you're doing.
Because if some